All right, welcome back. Let's have a look at calculating pressure within a hydraulic device. So before we go jumping into actually looking at how to do the calculation, there's a few assumptions that we have to look at using for this. So it all comes back to Pascal's law. Pascal's law says that pressure in a system that is enclosed, so there's no opening, pressure is equal everywhere. Now, a hydraulic device is a closed system with a fluid inside, and it might have different pistons, different size pistons putting forces, different, on different areas of this system, but forces and areas, they all have to create the same amount of pressure because it's all connected. So there's this assumption that if we do a little drawing here of a hydraulic device, and I'll just draw a really simple input piston, which will be this one here, and the output piston, which would be this one here. You can see the input piston is a lot smaller. The output piston is usually typically bigger because we want this force advantage. Pascal is saying that the pressure that's created here is going to be equal to the pressure that's created, say, here. And I'll just put pressure at spots 1 and 2. If there were more spots on this, then it would be 3, 4. They're all equal. Okay, now how do we calculate pressure? Well, we can calculate pressure in separate places. Okay, so if we look at the input side, we would take our what is our regular pressure formula is force over area. So we're going to do the same thing on each side. We're just going to use input values and then output values together, and they should come up to the same answer. Okay, so for example, we would use our input force and our input area here to calculate that input pressure. And on the right side, I guess I'll use O's now to show its output. I'll use force output and the area output to calculate that pressure. Now Pascal is saying those should come out to the equal number, and they will. So that being said, you can kind of reflect on math here a little bit. These are essentially going to be equivalent fractions. So you think, well, how did two different fractions come out to the same number? I could say, okay, well, give me a fraction that comes out to the number 2. Give me a fraction that will equal 2. And you might say, all right, well, 2 over 1 equals 2. Yep, give me another one. 4 over 2 equals 2. Those are equivalent fractions. 8 over 4 equals 2. And on and on and on. So, this answer here, it could be the force and area for this side. This one right here, it could be the force and area for this side. So their forces are different and their areas are different, but the ratios still come out to the same answer, which with a hydraulic device is the pressure. Okay, so this is the underlying assumption that helps us solve hydraulic device questions. You're going to get you'll get 3 values and have to solve for the missing 4th. And there's a few different ways you can do it. I'll try to show you what I think is maybe the easiest way, but we could set up a cross multiplication with 2 equivalent fractions together and then just cross multiply to find that 4th missing variable. You could do that. All right, so let's see what we can be asked about a hydraulic lift. A hydraulic car lift has an input piston with an area of 2 meters squared. Okay, that is my input area, and it has a force of 20 newtons. That is the input force also. Calculate the pressure. So to calculate pressure, because pressure should be the same everywhere, I can use 2 input values or 2 output values. I'm given the input ones here. So pressure will equal force over area. That means I would take 20 newtons and divide it by 2 meters squared. That gives me 10 pascals of pressure created here. Now it says if the car's output piston has an area of 480, what is the output force generated? So you've got to calculate that. So what do we know from this problem? Let's write down a few things. I like to usually draw a picture. It helps my visual sense of learning picture where everything is. You can list the variables and what they're equal to if that makes more sense for you. Okay, so I'm going to use the two input values from the question above. So I've got on my input side, area is 2 meters squared, and my force was 20 newtons. On the output side, you're given an area of 480 meters squared. Okay, you're asked to figure out the output force. That's what we don't know. Okay, so a few things. With hydraulic devices, these, because they're equivalent fractions, they have to increase in the same way. Like, for example, my easiest way to solve this is I look at the two things that I know. The two variables I know that are the same. I've got area and area. I can't look at forces yet because I don't know that one, but I can look at how much the area increases from piston 1 to piston 2 here. So how many times bigger did it get? Well, 480 divided by 2. It actually got bigger by a factor of 240 times. And I just took 480 and divided by 2. So here's the thing. The number of times greater that the area increases by needs to be the same number of times bigger that the force will increase by. All right, so if my area increased by 240, I'm going to increase the force by 240. So if I multiply 20 by 240, I will get 4,800 newtons. Simple as that. Okay, so if you can find the two that you know, in this case it's area input and area output, I can see how many times they increased by, and then just do it to the other one. You can also, let's set up equivalent fractions. Let's do this maybe the longer way. So I would go force input and area input are equal to force output and area output. Let's use some values here now. So that will be 20 newtons over 2 meters squared equal to, I don't know this value, but I know this one. Okay, how do we solve a nice cross multiplication question now? Like this. We take the two that we know, which are 480 and 20. We multiply them, and then we divide by the oddball here, who doesn't have a partner, and is 2. So in our calculator, we will go 480 times 20 gives us 9,600 divided by 2. And that also comes out to 4,800. All right, so they have to, basically the size and the area have to increase by exactly the same amount in order for their pressures to come out equal. Okay, now the last little thing to show you here, which is interesting and relates to mechanical advantage, is that this number right here, this factor, this number of times that the force and the area are multiplying by, is the mechanical advantage of that hydraulic device. So the mechanical advantage is the number of times it can multiply your force. That by definition was mechanical advantage that we talked about earlier. This is exactly that. If the area increases by 240 times, the force increases by the same amount. If the area increases by 2, the force increases by 2. the mechanical advantage is 2. Okay, so that's kind of the connection here between the forces and area. I hope that this was able to help bring some clarity in probably one of the more complex calculations that you'll do in science. So practice from what you have, and make sure that you ask questions. All right, take care. Thanks, guys.